welcome to example number 2. So if you recall what happened in the example, it worked out super nice. Just take a square root of both sides. We'll factor it, and it required the trinomial to be a perfect square. Well, obviously not every trinomial is going to be a perfect square. So the next step of this is to be able to create that perfect square if it's not already a perfect square. That's what this process is called, creating the square. So let's take a look at the example here. Not every quadratic expression is a perfect square trinomial. Completing a square is the process of finding the constant x squared plus bx to create that perfect square. This is kind of interesting. I never really thought about it like this. Yeah, you've got x squared there, right? And you're being added bx. What you're going to do is you're going to divide bx. You know, like that. And then completing the square is like, what's this? Well, that's going to be b divided by 2 squared, because that distance there is b divided by 2. And then when you go to write the equation, x squared plus b divided by 2, x plus b divided by 2 squared. That all probably seems like nonsense, but let's talk about the process of what you're actually going to do. That's just trying to give you like a visualization of why what I'm about to say actually works. So let's look at the second part here. All right, so you're going to write x plus 8x plus 5 in the form x plus p squared equals q. So we got to figure out a way to complete that square. Like plus 8x plus 5 is not a perfect square, right? Because 5 is not a square number. That's your first. So that's what you get. First thing you're going to do is subtract the 5 to the other side, right? Because what you want is the quadratic and the linear term isolated, right? And then figure out what are you going to add to both sides. What is the number that's going to complete that square? The b value is 8. You divide that by 2, you get 4, and if you square that, you get 16. So b divided by 2 squared is the number you're going to add to both sides. When you add 16 to both sides, you get 11 on the right side, and then you can factor x squared plus 8x plus 16 plus 4 squared. The whole idea is you're getting something that you can factor that way, right? And that's it. The next example will take this a step further, but we're going to practice doing that. So at this point, why don't you try this one on your own, and I will demonstrate it for you, and then you can come back after you have paused and tried it on your own and check against my answer. Okay, so I took the original equation, I added 11 to both sides to start. Again, isolating the quadratic and the linear term. Then I figured out what is the number that completes the square. I took the 6, and it doesn't matter that it's negative because you're squaring it anyway, right? So I just took 6, divided it by 2, and got 9. And again, if you had taken negative 6 and squared it, you would have gotten positive 9 anyway. So I added 9 to both sides, and I have x squared minus 6x plus 9 equals 20. X squared minus 6x plus 9 factors into x minus 3 squared. Again, that is the whole point of completing a square is to get it to be able to be factored like this. Okay. In the next example, we're going to look at what to do from this point forward. Okay. Let's look at example 3.